Hi, my name is Kruthik Alapati, and this is my presentation on Lab 1 charge tapes.
So the objective of this lab was to use experimentation and a computational model to understand charge and how objects can store that charge. So why is this important? It's because charge is intrinsic to the matter that caused it to experience force when placed in an electric field. It's determined by the amount of electrons, protons on the matter, and can be measured in coulombs. We use Coulomb's law and Newton's second law in this lab, and Coulomb's law says that two objects holding a charge can exert a force on each other. Most objects can acquire an excess or deficiency of negative charge when rubbed against other objects. Here you can see the concepts that we'll use for the lab and the formulas for them listed below. We use Newton's second law and Coulomb's law. In this experiment, the system are the two U-tapes A and B. The surroundings are the universe surrounding the tapes. The tape starts with a neutral charge. The only initial force on the tape is gravity. And to start, you would stick a piece of tape on the desk to create a base tape and create a charge U-tape by sticking a second piece of tape on top of it and ripping it off. You repeat this process to create the second charge tape. Assume the tapes have equal net charges and the charges are point charges. So the expectations are that the tapes should be attracted to neutral objects, repel each other, and if they're positively charged, be attracted to the negatively charged pen, and repelled if they are negatively charged. The observations were that the charged tapes repelled each other. They were attracted to my hand, which is a neutral object, and the charged tape was attracted to the negatively charged pen. Since they were repelling each other with no acceleration, this means the charges were relatively close to each other.
Here you can see the length, the width, and the mass of the U-tape, as well as the distance between the tapes, and the surface area of the tape, which was then used to calculate the number of atoms. So you can see in the calculations that I set the force of gravity equal to the force electric, which then allowed me to calculate the charge on the tape. And then I used the charge to calculate the number of deficient electrons. Then I calculated the surface area of the tape, multiplying the length and the width. And then I used the area of an atom, which is 10 to the negative 20 meters squared, which is calculated by multiplying the length twice, like by itself. And then we got the number of atoms on the tape. And I was Here I have my glow script code where I set up all of the constants we talked about in the last slide, as well as the equations needed to calculate the force due to gravity, the electric force, the number of atoms on the tape, the charge on the tape, and the number of electrons on the tape, as well as the ratio of number of excess electrons to the number of atoms. And we have our separations for tape B and tape A in terms of the force acting on each one for the model, and we have the statements displaying the calculations from the calculation section that I coded.
Here we have the glow script model showing the force due to gravity with the green arrow and the electric force with the orange arrows. You can see the statements that I coded earlier shown below. So the force due to gravity was 2.943, negative 2.943 E negative 3 newtons. The magnitude of charge on a piece of tape was 1.54397 E negative 8, which is basically the same number that we got from the hand calculations on earlier. The electric field on the tape B is shown there, and the electric force is also shown in vector format. And the ratio of excess electrons to atoms was 1.1 E negative 7, which is also almost exactly the same as what I got when I did the calculations by hand. On this slide, I have some reasons why error would have occurred during the experiment. The first being that the tape might have lost charge while being handled and coming into contact with charged or neutral objects. The second is that there's human error in the measurement of the tape length, width, and mass. And the third one is that the charges on each tape are likely slightly different. And the fourth reason is that the charge is not a point charge, nor is it probably equally distributed among the tape.
So why is it important to handle the charged tapes as little as possible? It's because it could lose deficient or excess charge when it comes into contact with neutral or charged items. And what if the electrons had a positive charge and protons had a negative charge? Well, not much would change about the observations. There would still be a repulsion that occurred, but instead of positive charges repelling, it would be negative charges repelling.